Okay, hello everyone. Hope you all had a restful and safe spring break. Now, I'm sure you all know we will be doing e-learning for a little bit longer. So we're going to try our best and move forward and just do what we did before spring break. Okay, so let's go ahead and talk about our very last form for graphing quadratics. But before we get there, I just want to do a quick review of what we saw before spring break. So we first have vertex form where the general equation was something like this: a times x minus h squared plus k. So for example, we could have y is equal to, let's say, 3 times x minus 2 squared plus 4. So that will be something of a equation that's in vertex form. In this case, my vertex will be at 2 comma 4 because I'm being shifted to the right 4 and right 2 and up 4. So there's my vertex. And so that's vertex form. And then we saw what was called the intercept form, where the general equation was written something like this: a times x minus p x minus q. So for example, we could have something like y is equal to 1/2, let's say x plus 4 times x plus 10. And in this case, in order to find the vertex, we first had to find the axis of symmetry. So our axis of symmetry, and remember that comes from our x-intercepts, which in this case are -4 comma 0 and -10 comma 0. So then our axis of symmetry, we would take the average of our intercepts and divide it by 2. So add them up, divided by 2, we get x equals -7. So that will give the x value of the vertex. And to find the y value, we simply go ahead and plug it in, our x, into the equation up here. So that looks like 1/2 times -3 times 3. So it looks like -4.5. So in this case, our vertex will be -7, -4.5. Okay, so that's what we did before spring break, is we saw what was called vertex form and what was called the intercept form. And now we're going to go ahead and see what the last form for a quadratic equation is, and that's called the standard form. And I should mention that as I'm doing this, please go ahead and take notes in your notebook or on a separate sheet of paper. Okay, so we're talking about standard form, and what the general form in this case is, it's ax squared plus bx plus c. Now, we did talk about standard form when we did polynomials, when we did factoring, right? So remember, that was when your exponents are written in order from highest to lowest. In this case, it's the same thing over here. Our exponents are written, first it's ax squared, and then it's bx to the first, and then c is the constant term. So then we're going to see how we can find the key features when our equation is written in this form. But before that, let's just go ahead and see a few examples of things that are written in standard form. So for example, let's say we have y is equal to 2x squared plus 10x minus 1. All right, that's in standard form, where in this case, my a is 2, b is 10, and c is -1. Okay, so that's one example. Another could be, let's say, 1/2 x squared minus 4x plus 50, and so and so. Okay, but the key thing that we should know is, here's how we can find the axis of symmetry for something that's written in standard form, and it's x is equal to -b over 2a. Okay, so this is very important. We're gonna be using this a lot when we work with standard form. So the axis of symmetry is the equation x is equal to -b over 2a. And let's go ahead and see a couple of examples of this and see how we can find the vertex given something in standard form. So for example, Suppose I have y is equal to 2x squared minus 8x plus 4, and I want to find the vertex. Okay, well, before that, let's first go ahead and look at the axis of symmetry, AOS. So again, this is negative b over 2a. So then we should first find our a, b, and c values. In this case, my a is 2, b is negative 8, and c is 4. So if we go ahead and plug in those values in here, let's see, we have negative b, so then we have negative 8 over 2a, 2 times 2. So that becomes positive 8 over 4, which is 2. So my axis of symmetry is x equals 2. So then, in order to find the vertex, we already know that our x value is going to be 2. And how do we find the y value? Well, we have the x value, so we can simply do the same thing as we did before. Plug it in, the x value into our original equation. So we have 2x squared minus 8x plus 4. And then this part you can do on your calculator. 2 times 4 minus 16 plus 4. And a minus 16 plus 4. So that looks like negative 4. And there it is. There's going to be our y value of the vertex, 2 comma negative 4. And then something else I should point out that's going to be very useful when working with standard form is how we can find the y-intercept. Okay, so again, let's go ahead and go back to our equation up here. And if I want to find the y-intercept, remember, we always want to use x equals 0. So then let's go ahead and plug in 0 for x. So I have 2 times 0 squared minus 8 times 0 plus 4. Okay, and let's go ahead and find what y is. Well, 0 squared is just 0 minus 8 times 0 plus 4. And I think we just get positive 4, 0 minus 0 plus 4. So then our y-intercept, let's write it as a point, is 0, comma 4. Okay, and then if you notice, whenever we find the y-intercept given an equation that's written in standard form, right, the pattern that I want you guys to see is we're always going to get the answer as my c value. So this right here will always be my y-intercept, right? Why is that? Well, because to find the y-intercept, we're going to plug in 0 for x. So these two terms will always become 0, which means whatever my constant term is, which is at the end, will just be my y-intercept. Okay, so that's a nice little shortcut of how we can find the y-intercept given something that's written in standard form. Okay, but let's go ahead and see a few more examples just to kind of get the hang of this. So let's say we have y is equal to negative 3x squared minus 4. And again, let's first go ahead and find the vertex. But of course, we need to find the axis of symmetry first. In this case, my a is negative 3. My b is actually 0. C is negative 4, right? Because we don't have an x term there. So if you like, I can put a plus 0x. So then let's go ahead and find the axis of symmetry using our formula. So we know it's going to be x is equal to negative b over 2a. So let's go and plug everything in. So I have negative 0 over 2 times negative 3. So that's just going to be 0. 0 over anything is just going to be 0. So that's going to be my x value of the vertex. So for the vertex, my x is going to be 0. How do I find the y? Well, once again, we're going to go ahead and use our equation that we were given right here. So let's go ahead and do y is equal to negative 3 times 0 squared minus 4. So I get negative 3 times 0 minus 4, or just negative 4. So there it is. There's my vertex. And then lastly, let's go ahead and find my y-intercept. I'll do it over here. Okay, so if you remember the shortcut that we saw above, we're gonna see that our y-intercept would just be this value right over here, meaning negative 4. But let's just go ahead and double check by plugging in x equals 0 and see what's gonna happen. So I get y is equal to negative 3x squared minus 4. So negative 3, 0x squared minus 4. And again, we're going to get a 0 here. Negative 3 times 0 is 0. Minus 4 is negative 4. So again, we see that what we found before, the pattern is the same still. So our C value, which is again over here with negative 4, that's always going to be my y-intercept because everything before will cancel out to be 0 when we find the y-intercept. Okay, so let's go ahead and do one last example just to kind of really get the hang of this for standard form. So let's say I have y is equal to 1/2 x squared minus 6x minus 3. And again, same deal. Let's go ahead and first find the axis of symmetry. And again, we're going to have negative b over 2a. So let's go ahead and find our values. A is 1/2, b is negative 6, c is negative 3. So in this case, it will be negative b, so negative 6 over 2a, and a is 1/2. Okay, so negative 6 becomes positive 6. And on the bottom, if you do 2 times 1/2, that's just 1. So I guess 6 as the axis of symmetry. And then once again, for the vertex, we know our x is going to be 6 because that's the same as our axis of symmetry. And then for the y value, we can go ahead and plug in 6 into the equation and then simplify. So I get 1/2 times 36 minus 6 times 6 is 36 minus 3. So that's 18 minus 36 minus 3. So that looks like negative 21. And there it is. So that's going to be my vertex. The y is negative 21. And then last but not least, let's go ahead and find our y-intercept once again. And again, if you remember the shortcut, we know our y-intercept, which is just gonna be our c value, which is 0, negative 3. So I can just put that down right away, 0, negative 3. But for the sake of doing this, let's just go ahead and see what would happen if we plug in x equals 0. If we did it the long way, we should end up getting the same answer still. So if I do x equals 0, I get y equals 1/2, 0 squared minus 6 times 0 minus 3, plugging in 0 for x. And then we see that we're going to have 1/2 times 0 minus 3, which will just give us negative 3. So our shortcut does work, right? So again, the nice thing about standard form is that we're going to end up getting the y-intercept straight from the equation after we plug in 0 for x. Okay, so that is everything for standard form actually. Next time we're going to see how we can graph parabolas when something's written in standard form, but it's everything we saw today pretty much. We're first going to find our vertex and then using the vertex to graph the rest of the parabola. Okay, so please go ahead and take notes as you watch this and then go ahead and try the homework. And then as always, make sure you try the homework and let me know if you have any questions. And I hope you guys have a great rest of your day.